Okay, fine. Very good afternoon. I hope my voice is audible. This is
Yes,
Sagar
sir.
Kondekar.
Yes, sir. Your voice is clear. Yes, sir. Sagar, sir, your voice is clear.
It is clear, na? Fine.
Yeah. Gaurav, sir, should I start? Gaurav, sir. Good afternoon, Sagar, sir. I am the host for today's session. So please give me the chance to introduce you to this session. Yeah. Good afternoon to one and all. A warm welcome to the 16th Faculty Induction Program organized by UGC Malviya Mission Teacher Training Center and Dr. Babasaheb Ambedkar Marathwada University. And I am Sachin Gupta, an assistant professor from Wilson College, Mumbai. First of all, I would like to thank the organizing committee for giving me this opportunity to introduce today's eminent resource person. It's my privilege to introduce Dr. Sagar Santosh Kondekar, who is currently serving as the Director and Associate Professor of Economics at the School of Social Sciences, SRTM University, Subcampus Latur. Sir holds an MA, PhD, and qualified CET in economics. He has an extensive academic and teaching experience spanning over 17 years in both undergraduate and postgraduate levels. Dr. Kondekar's academic expertise includes SPSS, R, data science, international economics, growth and development, statistical methods, and urban studies. His strong interdisciplinary orientation has significantly enriched both teaching and research in economics and social sciences. He had made noteworthy scholarly contributions with 15 research papers published in reputed national and international journals, along with 21 books and book chapters as an author, co-author, and editor. He has also developed a recognized MOOC course, contributed to academic translation work in SWAM NPTEL courses, and successfully completed certificate courses from IITs, earning gold and silver medals. In addition to his academic achievements, Dr. Kondekar sir has been actively involved in academic administration, serving as a member of 14 important university level committees like NAC, IQAC, SPOC, International Student Center, and many more. Sir has also contributed to Board of Studies at various universities. He has participated in several international and national conferences, conducted workshops on research tools, publication ethics, and anti-plagiarism. Sir has completed 2 research papers and one is ongoing. Dr. Sagar Kondekar sir's vast experience in teaching, research, and academic governance makes him an eminent resource person, and his presence will greatly enrich today's session. So, please join me in giving a warm welcome to Dr. Sagar Kondekar sir. Over to you, sir.
Thank you, Gupta sir. Thank you.
Thank you, sir.
So, fine. Without spending much time, I think we should start our session. So,
Correct.
I'll start sharing my screen. Let me check whether it works. Okay, fine. I hope my screen is visible to you all.
Yes, sir. It's visible, sir.
Fine. Just make me a few arrangements at my own.
So you can go to the slide share.
Yes. Whether my first slide is visible?
Yes, sir. Clearly visible, sir.
Okay.
Yes, sir.
And I hope my voice is loud and clear to you all.
Yes, sir. Yes, sir.
Okay, good. Let me start with the session. See, now the topic given to me is statistical thinking, inference, and responsible use of AI in research. And before starting the session, let me make few things clear. I hope my this cursor is also visible, and if I'm writing something, I think this is also visible to you all, because
Visible,
all
sir.
these things will be used during the session, and it has its own importance. So, is it visible to you all?
Yes, sir.
Okay,
Yes, sir.
fine. So in my session, see, I am not the only person who is going to talk. Meanwhile, in between the session, I'll ask many questions and I'll expect responses from your side. Either you can unmute yourself, or you can means communicate me through chat. Fine. So the topic is statistical thinking. So the first part is the statistics. And in that again, inferential statistics is there. And finally, we'll be dealing with the responsible use of AI. This whole session is actually classified into two different, say that, sessions. In the first session, I'll talk on the core statistical thinking in research, where I'll try to make you familiar with the variables and a few research terminologies. As I know that we all are the faculties, and more or less we all are aware of most of the concepts which we are going to discuss here
आता काय करायचं ते?
in this session.
त्याच्यावर तो लाल शाही मारायला लागलीत सर. लाल
Still,
शाही करायला लागलीत.
I think someone
मी ऐकलं.
is unmuted. Please, may I request you to
बोलले ना
mute
आपण,
yourself?
मी
A
कन्फर्म होतो
person.
ते करता येत नाही हे कोर्स करत असताना. आता तो कोर्स ऑर्गनायझर म्हणते करू नका म्हणून.
Sir, you
आता
can also mute from your side.
सरांना बोललो पण ते
Sir, can
असं कुठं असते म्हणे.
number 19, please mute yourself.
Okay, I'll request all participants, please mute yourself so that lot of noise. Fine.
सॉरी
Uh,
सर.
yes. So, there will be two sessions. In the first session, I'll be talking on the variables and research terminologies. I'll talk on measurement scales. Then I'll talk on data types, categorical and numerical. And then I'll talk on choosing appropriate statistical methods. I know that we all are the faculties, and somewhere we all are aware of, well aware of few of the concepts. But still, in during first session, I'll try to revise few things in a different perspective. Fine. In the second session, I'll talk on the inferential statistics. Then I'll talk on hypothesis testing framework. Then correlation regression, and at the end, I'll talk on the role of AI in statistical analysis. Both the sessions are designed in a such a way, nowhere we are going to use any formula. Again, I repeat, nowhere we are going to use any formula. We are not going to use any formula. Without formula, we'll try to understand the statistical thinking in the research. Fine. Now, let me take you to the further slide. So here are a few fundamental questions. These are the questions which we'll try to address during these two sessions. So the first question is, should statistical techniques be planned before data collection or after data collection? यानी डेटा कलेक्शन करने से पहले स्टैटिस्टिकल टेक्निक्स शुड वी प्लान, और आफ्टर द डेटा कलेक्शन इज द फर्स्ट क्वेश्चन. Second question, can any statistical test be applied to any type of data? Can we apply any statistics on any type of data? Many times it happens that when our research students or means the people, they collect some data, and they directly comes to a person who knows or who is familiar with the statistics, and they simply ask to perform the statistical tools on that data. So can we blindly apply any statistics on any type of data? So that question also that we'll try to address during these two sessions. Is it necessary to memorize the formulas for statistical analysis? Is it really necessary that if person wants to use the statistics, is it necessary that you need to have studied that statistics subject as a subject during your graduation or post graduation? Is it? So that question also we'll try to address. Do we use statistics just to calculate numbers, or to extract meaningful evidences? What matters more, variables, process, or interpretation? Okay. Most of the time, what the researchers or what the faculties or the research students, what they feel is the process is very important. Once we are familiar how to proceed with the data and how to apply the hypothesis test on the data, then that's it. Okay. Means we feel that our research is now over. Is it so? If the software or AI calculates everything, then what is the role of researcher? What is the role of researcher? If AI is doing everything and if the softwares are means they'll give you the output, then what is your role? And finally, what improves the research more, whether it is a large data or correct measurement? So these are a few questions which I think I kept it in my mind, and I thought means I have designed this session to address these questions. So we'll come back to these questions at the end of my two sessions. So what are the steps in research? These are just usual formal steps actually. So usually we choose the research topic, then we go for the literature review, then we find some gap and then we identify the research problem, then we frame the objectives, correct? And once we frame the objectives, then we start defining the concepts, we start constructing the variables, then we decide how to measure the variables, and here comes the measurement scale. Then we collect the data, survey, interviews, and there are other methods also. Then we apply statistical technique, and then we interpret and we report the results. So more or less, these are the general steps in research. So far this session is concerned, I'll mainly talk on these two things: construction of the variable and how to measure the variable, and the application part of the statistical techniques, that too using AI. But AI part comes little later. By the end of these two sessions, we'll come to the AI part. But before that, let me first start with the variables. Now, sorry. Suppose someone wants to work on the assessment of physical fitness level among the school students, and the variable is fitness. Now, we all are the faculties, so we are more or less familiar with the variable, what is the variable mean and the things. Suppose there is a variable fitness and I just wanted to collect information on the fitness. So what type of the question that I should ask my respondent? Can someone tell me? Anyone? If we wanted to collect the
And
information
mass.
of the on the fitness of the students, what type of the question that we can ask to a
Sir,
respondent?
their age, height, and mass to
Good.
calculate BMI.
What is your good name, sir?
Sachin Gupta, sir.
Sachin Gupta, sir. Okay. Height, weight, so that we can compute BMI. Fine. Body
Age.
mass index. Okay. That is one of the method. Okay. Another way. Is there any another way that we can ask or we can collect the fitness information? See, why I'm asking such questions? Answer is, in means in few cases there are chances that someone is asking simply a question, do you consider yourself physically fit? And if you are getting the answers in yes and no, then is it the means authentic way that we are collecting the information? Okay, answer to this question is no. The way the Gupta sir said, if we are collecting the information using the different kind of questions, like say that here BMI, if I'm counting the BMI, or if I'm counting resting heart rate or push-up counts in a particular 1 minute or 2 minutes, then I'm going to get the responses in numbers. Okay, I'm going to get it in numbers. Whereas in the case A, I'm just going to get only the opinion. And how will you define that yes and no are the valid? So validity authenticity. There are many things. So whenever we are measuring the variable, we should measure the variable in a proper way, right? Let me take the another examples like say that income. How do we measure the income? Suppose I'm collecting information on the income. What type of question should I ask? अभी गुप्ता सर छोड़ के बात करेंगे बाकी लोग. If you participate more, I think उसमें ज्यादा समझ में आ जाएगा. Because see what part I am going to cover, I'll start with the variables, then I'll go to the statistical techniques, descriptive statistics, inferential, hypothesis test, correlation, regression. ये सभी चीजें without formula will try to understand. But for that, first we need to understand how actually we measure the variables. So your participation is very important. So how do we measure the income? How do we collect the information on income? What type of questions we can ask to the respondents? Can I ask the question like means how much is your income, and I have classified it into the groups like less than 10,000 rupees per month, or 10,000 to 15,000, 15,000 to 20,000. Should I make the categories, or should I simply ask how much is your actual income in rupees? Which method is good? Which method is more appropriate? Method A or B? What is your opinion? Actual monthly income will work properly, or the categorical income will work with me? So far the statistical treatment is concerned.
Method A, sir.
Method A. Why? Why not B? If I'm asking you what is your monthly income, and people are saying say that 25,000 rupees, someone is saying say that 32,000 rupees, someone is saying zero income, no problem, someone is saying 17,000, someone is saying 8,000, fine. So fine, I just wanted to make few things clear. Some participants may feel this is good, A is good. Some may feel B is good. If A is good, why A is good? If B is good, why B is good? So we are going to talk on these things. Fine. Simply, if I collect the information like B, I can convert it into the categorical things. But if I collect the information in A, I cannot convert it into B. Right? There are many things that we'll discuss little later. Let me take you to the satisfaction level. Suppose I'm asking you a question. How was the morning session, or how is the this session? ये session कैसा रहा? How much you are satisfied with the session? So how will I measure it? How will I ask a question? So for the satisfaction is concerned, कैसे पूछेंगे इसको हम? Yes, please. There are many people in this meeting. Whatever is your answer, please. कोई आंसर गलत नहीं
Good
होगा.
satisfactory.
So on a
Pardon?
scale of 1 to 5,
1 to 5
Good
scaling.
satisfactory.
Fine.
Unsatisfactory.
Likert
like
scaling, right? Highly satisfied. Fine. Then satisfied, then neutral, then unsatisfied, and very unsatisfied kind of thing. Fine. This is one of the way. But suppose at the end of the session, if I conduct one class test, MCQ type, and that is a quiz, online quiz, and you all will get few marks, right? Some marks. And on the basis of those marks, if I came to know that, okay, a person A, person B, and person C, and person D, who is satisfied, who understood both the sessions well, and who misunderstood, or किसको कम समझ में आ गया, ठीक है ना? So how am I going to measure the satisfaction? There are different ways. Again, there is no thumb rule. There is no thumb rule to measure the variable in a particular way. Usually, what happens whenever the variable like a satisfaction appears, usually we opt for the Likert scale, but it is not the case. Depends on what actually you wanted to measure and how you wanted to measure. So there are different ways using which we measure the variables. The story, sorry, story is same with the social media uses. Simply, very frequently, frequently, less frequently, or once in the week. There are different ways that using which we can collect the information for the social media uses. Now, why measurement needs serious attention? Reason is, see, the variable becomes meaningful only when they are measured correctly. What does that mean? Suppose there are person A and there is a person B, and I have asked a question, how much you are satisfied with these sessions? Suppose A thinks he is very satisfied, B thinks he is only satisfied. But as the session ends and both the persons are approaching towards house, B starts thinking, उसको कुछ ideas revise हो जाता है, and he thinks, no, I am not satisfied, I am actually very satisfied. And the A person may think कि अरे नहीं, मुझको उस वक्त समझ में आ गया था, but there are few errors and few misconceptions कुछ अलग है. Actually, I am not very satisfied, but I am just satisfied, right? So these opinions can change. But if both the persons have attempted the exam and A person have got, say that 9 marks out of 10 and B person have got 6 marks out of 10, these marks are not going to change, right? Things are like, if you are using only opinions may change, but if you are collecting the information in numbers, then those numbers usually they don't change. Statistical techniques depends entirely on how the variables are measured. Incorrect measures takes you to wrong direction. Data cleaning cannot help. Sometimes researcher thinks that data cleaning can help me. But no, if you have measured the variables incorrectly in a not proper way, then data cleaning will not help you. Good measurement reduces error and it increases the reliability. So these are the few points which I think we all should consider. See, uh, everything that we can and cannot do statistically depends on only one step. That is how we measure the variable. How we measure the variable. The question format decides the measurement scale, and the scale decides which statistics can be used or cannot use. A very important thing is we cannot use any statistics on any type of data. Again, I repeat, suppose I am having a data with me, I cannot blindly apply any statistics on any type of the data. First, we need to understand what type of my data is, what type of my variables are. Once we identify the type of the variables that we are carrying, then only we can apply the different statistics, and it takes you to the proper conclusions or appropriate conclusions, right? So what is more important in research? Is it a collecting data or measuring correctly? So what is important in the research? Collecting data, simply asking the questions, or measuring the variables correctly. The way in the first example, as I said, when we are working on the fitness and I'm asking simple question, are you fit or what, or on the Likert scale, how fit you are, 1 to 5. And in another way, if I am collecting data on the BMI and then I am coming to a conclusion. So which method is good? Which measurement is correct? Again, it varies from researcher to researcher and it depends on you that how you are measuring your variable. And in whole this process, how does the AI help us? AI किस तरीके से help करेगा? So we'll talk on this little later. Now, let me take you to the further part. Before again entering into the statistics, let me first make you all familiar with the basic terminologies. Most of the terminologies you all are familiar with, but still I just wanted to revise few part. Okay, just a second. Fine. So let me start with the universe, population, sample statistic, population parameter and data. Okay, can someone tell me that what is sample statistic? There are two things. Whenever we are going to apply econometrics modeling or statistics, techniques, statistical techniques, two terms are very important: sample statistic and population parameter. So, is there anyone who can tell me what is the statistic and what is parameter? Anyhow, we are going to discuss on these things, but I just wanted to know that who is my audience and whether you are familiar with all these concepts or not. So accordingly, I'll go into deep into these things, or otherwise I'll just introduce you and I'll go to the further slides. What is sample statistic and parameter? Fine. Let me take you to the further slide. See, in research, we are having these two concepts, universe and a population, right? In natural sciences like chemistry, physics, medical sciences, usually the universe and population are means they consider both the terms as the same, right, as a synonym. But in social sciences, universe is somewhat different than the population. Universe is actually associated with the theme, your research theme, and population is actually associated with the scope of your study, or population actually is a part of the universe for which you are going to make the conclusions. So in social sciences, we usually work on the population. In social sciences, in commerce and management, we usually work on the population. In universe, there are many populations. In universe, there are many populations. Suppose if I am working on the, say that the hemoglobin level of the female students who are studying, completing their graduate studies, right? So all the female students from all over the world becomes the universe. But I'm working on the, say that the female students studying in, say that the western part of the Maharashtra or the Marathwada or the Vidarbha or a particular region where the scheduled tribes are more in numbers. So that is population. So what is population? Population is a part of universe for which actually we are working. We usually draw findings for the population. We usually work on the population only, right? Now, in a population, how do we work in research? In population, there are many elements, and those elements are carrying different characteristics, right? We cannot reach to each and every element. So this is basic means research kind of part, and all we know this thing. We cannot go to each and every element. So what we do, we identify the sample, we collect the information from the sample, and there are different methods of sampling. We choose samples using different methods. Like this is one of the method, or this is another method, or this is another. There are different naming to these methods, right? But anyhow, from population, we identify the samples, and from the samples, we collect the information. What actually we collect from the samples? Information. But what is that information? कौन कहेगा? कौन बताएगा? What actually we collect from the sample? We collect the characteristics of the population. What we collect from the sample, we collect the characteristics of the population. Now comes the important question, and here are the two questions. Sorry. How can the characteristics of sample represent the characteristics of entire population? What I mean to say, you have identified the samples, you have collected the information, you have collected data from the sample. That's fine. Data is nothing but the characteristics of population. Now tell me, how can the characteristics of sample, because you have collected only sample data, na? So how can the characteristics of sample represents the characteristics of entire population? Is it possible to achieve 100% accuracy in the conclusion? Whether the characteristics that we collected through samples represents the population characteristics exactly? What about the authenticity? What about the validity? What is your opinion on this? I hope you understood my question. अगर हम सैंपल से इंफॉर्मेशन ले रहे हैं, तो सैंपल के आधार पे जो हम निकाल रहे हैं कंक्लूजन, वो हम पॉपुलेशन के लिए कैसे जनरलाइज कर सकते हैं? Because your sample is very small part of the population. So is it good idea to choose sample? This is all means research methodology में यही कहा जाता है ना कि you choose sample and you collect the information. But your sample is very small part of the population. Then what about the authenticity? Who will answer this question? Or should I go for each and every element? Suryavanshi sir, Kale sir, madam, someone? Shankar sir, Yadav sir? Okay. I hope you understood this question at least. So,
Yes, sir.
from, yes, please.
So we have understood the question, I'm saying. So sample cannot represent 100% characteristics of the population.
Then why we are using the samples? Then why means why to use sample? See, again, the thing is, what I just wanted to highlight here is we are choosing the samples, we are collecting the information, and on the basis of this information, if let me take you further, what we are collecting actually from the sample, we are collecting the information through variables. Variables are nothing but the characteristics of the population. And on these variables, we give the statistical treatments, right? What is sample? Sample is actually a representative of the population. And there are different methods, as we all know, probability sampling, non-probability sampling, correct? Sample should be as such that it should represent the population characteristics in a proper way. So once we identify the sample, whatever the data that we collect, that data represents the population characteristics, and we should keep faith on it, right? And it is valid thing, it is authentic thing, right? If you have chosen samples randomly using probability sampling, तो उसको और ज्यादा फिर उसको पावर आ जाता है, ठीक है? So once we collect the information from the sample, we give the statistical treatment on it, we compute something. So these are the terms like means, variance, standard deviation. There are different terminologies that we use in the statistics. As of now, आप इसके ऊपर ध्यान मत दीजिए. Those who are having the background of the statistics and those who are not having the background of statistics, little later will understand what actually the statistics is and how it works, right? So यहाँ पे सिर्फ समझ के ये लीजिए कि we collect the information from the sample and we give treatment, statistical treatment, and we compute something and we receive something from the sample. And whatever that we receive from the sample, that is known as a sample statistic. So what is sample statistic? Statistic and statistics are different. Statistics is a subject, whereas this statistic is actually the output from the sample data, right? So this is known as a sample statistic. Once we get the sample statistic, on the basis of a sample statistic, we estimate something about a population. We start saying something about a population. And when we start saying something about a population, that is known as a population parameter. So what is the scenario here? We cannot go to each and every element of the population. So we choose a sample. We choose sample very wisely, very carefully. And from the samples, we collect the information, we collect the variables, data. And on that data, we give the statistical treatment. And from that treatment, we get some outputs. Those outputs are known as a sample statistic. And on the basis of these sample statistics, we infer, we estimate, we say something about the population, and that is known as a population parameter. And then here comes the statistical methods. So where does the statistical methods comes into the picture? In research, statistical methods comes into the picture here when we collect the data, sample data. किसी भी रिसर्च में वी आर नॉट गोइंग टू अप्लाई स्टैटिस्टिक्स ऑन एक्चुअल पॉपुलेशन डेटा. We are not able to collect the population information except census. We usually collect the sample information and we we obtain some results using statistical techniques, and on the basis of these results, we infer, we estimate, we predict something for the population. So this is the way actually the statistics work. Now, so I hope you understood these two terms. Sample statistic you have understood, and population parameter. In every research, we only work on the sample statistics. Again, I repeat, in every research, we only work on the sample statistic. We only work on the sample data. On the basis of these results, we estimate the population parameter. That's fine. But we never work on the population data. We work on the sample data. So these are the few terms that we need to understand. That is why I thought to make you familiar with these terms. I hope it is clear. Now, I'll come to the variable. What are the different types of the variables? Please tell me. You all are the faculties, correct? Now tell me, what are the different types of the variables? Let me check in the chat box. No. I'm more interested in the answers, not in the present. Now there are many present things are there. Please, who will answer? What are the different types of the variables? Variable types. So there are different types of the variables like categorical variable, non-categorical
Independent
variable,
variable.
independent variable, dependent variable, discrete variable, continuous, non-metric. You go to new book, you will find new type of the variable, correct? But if I take you little further, variables are actually classified into only two parts, two types. Either you are having the non-numeric variable that is known as a qualitative variable, or you are having the numeric variable or the quantitative variable. Or in simple terms, you are having a variable where you are going to get the response in numbers. If I am asking you your age, your income, number of members in a family, you are going to answer me in the number. And if I am going to ask you, how is the lecture today on a Likert scale, right? How was the food today? Was it spicy? Yes, no type questions. So whatever question, the question which cannot be answered in numbers is known as the qualitative variable, right? In a simple term. So there are different types of the variables. It depends on the type of that term that you are using. Accordingly, sorry, the type of the variable changes. But variables are classified into only two parts, qualitative and quantitative. Now, qualitative and numeric. Now, how to measure these variables? How to measure these variables? And for this, we need to go to the measurement of scale. Now, what are the measurement of scale? Again, there are four different measurement of scale. What are they, and how they works in the statistical this thing treatment? There are four measurement of scales: nominal scale, ordinal scale, interval, and ratio scale. But when we enter into the softwares like R, Python, or MATLAB, they consider only three types of the measurement scale: nominal, ordinal, and third is a scale. Scale is nothing but it is a combination of interval scale and ratio scale. Now we need to understand what is the meaning of nominal, ordinal, interval, and ratio scale. I know that most of the faculties are well aware of this scale, but still we need to revise this because whatever the inferential statistics that we are going to deal in the next session, before that we need to understand exactly what is the difference between nominal, ordinal, and scale. Because once we understand what is nominal, ordinal, and the third part scale, accordingly you can choose the statistical tools. We cannot apply any statistics on any measurement scale. Once we understand nominal, ordinal, and scale, accordingly we can choose the statistical techniques. That is why this part is very important. So what is nominal scale? Nominal scale is actually simply a kind of a categorical data. Qualitative data, it is alphabetical, yes, no type question, or kind of gender. For example, if I'm asking a question, what is your gender? How am I going to get the responses? Either male or female, right? Either you are equal to male or equal to female, or you are not equal to male or not equal to female. So in mathematically speaking, nominal scale, we can only apply equal to and non-equal to sign in the nominal scale type of data, right? Now, what are the examples? Gender is a nominal, religion, category, occupation, type of house, yes, no type question, agree, disagree, right? So these are few examples of the nominal scale. You go to any corner of the world, either any researcher either working with the nominal scale, ordinal scale, or interval or ratio scale, or that is a scale. Third is a scale. इंटरवल रेशियो छोड़ दो, उसको एक करके आप स्केल कहने वाले हम लोग. What is ordinal scale? Ordinal is actually, again, it is a qualitative, it carries the qualitative characteristics, but it carries the property of order, right? For example, spiciness of the food: mild, medium, spicy, extremely spicy, right? So again, here, what mathematical treatments that we can perform here? Equal to, not equal to, greater than, or less than. So mild is less spicy than medium. Medium is less spicy than medium spicy. Spicy is less than the extremely spicy, right? So that is the thing. So greater than and less than comes here in the ordinal scale. Now let me take you to the example again. Pain very high, high, normal. Now here a very important thing is the distance between these two categories. Suppose I'm considering a pain as a variable. How much, whether the distance between a high, very high pain and high pain is equal to the distance between normal and low pain? Or how will you measure the distance between these two different, say that the attributes? It is quite difficult. Very satisfied and satisfied. This gap, how will you measure the gap? Is it equidistance? No. You have classified it into only 5 things: very satisfied, satisfied, neutral, unsatisfied, and very unsatisfied, right? So again, this ordinal scale is having its own limitations, right? Now let me take you to the interval scale. In interval scale, we get the responses in numbers. So here we only get the responses in numbers. So this is a numerical variable, right? And here the 0 is actually just a arbitrary 0. What does that mean? For that we need to understand the examples. IQ score. Is there any person whose IQ is 0? No. Any living person is having somewhat IQ. IQ is never 0 for a living person. IQ is never 0. No. Time. There is no 0 time. 0 time is not there. Right? 0 been considered as just a starting point, arbitrary point, but there is somewhat time. Temperature. Usually in a normal language, generally when we speak, it was 0 Celsius. No, 0 doesn't exist. 0 means does not exist. Actually, 0 is nothing. Here it is arbitrary. There is somewhat temperature. CGPA score. If you are going for an examination, there is something somewhat CGPA. CGPA is never 0. There is somewhat some number is there, right? So in interval scale, 0 has no meaning, or it is just arbitrary. It is just arbitrary. Now let me take you to the ratio scale. What I'm saying, you will understand once we understand the ratio scale. What is the difference between ratio scale and interval scale? In a ratio scale, there is a true 0. So in ratio scale, we are having the true 0 point. What does that mean? Let me take you to the examples. Suppose we are having the variable like cells, and I have collected information that is 0. It means that salesman could not sell not a single unit. Zero means the absentee of sell. Monthly income zero means no income. Income is absent there. Zero marks means student wrote many pages, but he could only earn 0 marks because all the answers were wrong. This 0 has meaning here, right? In the ratio scale, 0 has meaning. Blood pressure 0 means that person is dead now. Pulse is 0. Oxygen level is 0. Cost of production is 0. So here in every example, this 0 is having meaning. This 0 has somewhat meaning, right? I hope you understood this. Now, so this is a summary table where the nominal, ordinal, interval and ratio scale. The richest scale is the ratio scale. And if you are having the variables or if you are having the data from these two scales, interval and ratio, then we can apply plenty of statistical treatments. And if you are having the data from the nominal and ordinal kind of scales, then I think we are having limitations to apply different statistical techniques. Why I'm saying this, we'll understand little later. Nominal and ordinal, both the scales are they are considered as a qualitative variables, whereas interval and ratio altogether they are known as a scale variables, and these scale variables are known as a quantitative variables. So interval and ratio are the scales where we are going to get the responses in numbers only, right? Now, so again, I'll come to the conclusion here. As we already have seen that there are 4 different types of the measurement of scale: nominal, ordinal, interval, and ratio. And previously, as we already have seen that we classify data into 2 types: qualitative data and quantitative data, correct? Now, as we move from the left to right, we can apply more and more statistics, right? Now, to make it more brief, if I combine interval and ratio together, this is a scale, right? So nominal and ordinal, they both are known as a qualitative variable. Now the question comes, in a few cases, somewhere we use the Likert scale. What are the Likert scale? Likert scale are like 1 to 5. We provide some range 1 to 5, and we ask a respondent to choose opt for a particular this thing attribute, right? But though it is in a number, actually ordinal are considered as a qualitative variables. Fine. So nominal and ordinal variables are a qualitative variable, whereas a scale is a numerical variable. And as we already have seen that numerical variables, numerical data is having huge scope for the statistical treatment, whereas the nominal and ordinal data is having a less scope, limitations for the statistical treatment. Fine. Now, all after this means so far this session was concerned, we try to understand what is a variable, what is sample statistic, what is population parameter. We also try to understand what is nominal, ordinal, and scale data. Now, uh, let me ask you few questions. So here are the few examples, and let me ask you pin code. What type of variable is this? We already have seen that there are only 3 types of the variable: nominal variable, ordinal variable, and scale variable. Now forget about the qualitative and quantitative. Huh? We'll start talking in this sense. There are only 3 types of the variable: nominal variable, ordinal variable, and a scale variable. Scale variables are in the numbers, numerical variables. Nominal and ordinal are the qualitative variables. Now tell me, pin code. Every city is having its own pin code. So what type of variable is this? Nominal, ordinal, or scale? Who will tell me? Patil sir? Yes, scale variable. Okay. Only one answer. Is it a scale variable? Simply because of it is in numbers? See, only numbers doesn't make it scale variable. Again, what are the pin codes? Pin codes are nothing but kind of a codes given to your city for the identification of the city, right? It's kind of coding. The basic nature is the city. City is again Pune, Mumbai, or Kolhapur, or Ahmedabad, whatever. They are in qualitative thing. Again, mobile number. Huh? If my mobile number starts with 99 and your mobile number starts with 77, does that mean that I am superior than you? No, it is not like that. Bank account number. If someone's bank account number starts with, say that 34, and someone other person's bank account number starts with 5, 6, and something, does that mean that 56 that account number starting with the 56 is having lot of money in the account, and account number starting with 34 is having less money in his account? No, this is not the way it works. Bank account number is again a nominal variable, nominal scale. Pin code is again a nominal scale. Mobile number, nominal. It is nominal. Population of a country, it is a scale. Yes, distance between Mumbai and Pune. What type of variable is this? Who will tell me? Distance between Mumbai and Pune. Though there are chances that few participants may feel ki, sir, very simple questions you are asking, but please pay attention to this, because the next part, when we are going to talk on the hypothesis testing, regression, and modeling part, these are the things only it will help you to understand those things. Okay. So distance between Mumbai and Pune, what type of variable is this? It is a scale variable. It is scale variable, right? So annual income, again, annual income is a scale variable. Income group, tell me about income group. If I categorize the income group less than, say that 10,000, 10,000 to 15,000, 15 to 20,000, income group, what type of variable is this? It is a nominal, ordinal, or scale variable? Who will tell me? Income group, let me check in the chat box. Pankaj sir, scale variable. According to Pankaj sir, it is a scale variable, but it is not a scale variable. As I said,
Is
there
it
is a
nominal?
categorization, income group, less than 10,000, 10 to 15,000, 15 to 20,000. Categories, when there are the categories, then it becomes the ordinal. Ordinal means there is a order, right? The second order is greater than the previous order. Third order is greater than the. So again, we all need to understand what is nominal variable, what is scale variable, and what is ordinal variable. Once we are able to identify the type of the variable, then and then only we are able to understand the type of the statistical technique that we can apply. Again, a very important thing. See, we all know, we all are using artificial intelligence. I know. Uh, Many times it happens that we collect the data, and uh, we take that data to a person who knows the statistics softwares. That person normally he apply any statistical technique on your data. He gives you with the results, with the hypothesis testing and the modeling and the things, and we also feel very satisfied because we also have applied something, and we put it in our research and we publish it. Is it the valid way? Answer is no. A reason is that we cannot blindly give statistical treatment on any type of the data. Okay, a person who is giving the treatment on your data, he don't know your objectives, he don't know the meaning of your variables. And though that person gives us with the hypothesis testing result and the modeling, we actually don't know the meaning of those coefficients or the numerical outputs which has been given to us, right? So first we need to understand what type of the variables that we are having with us. So this is very crucial part actually. We need to know what type of variable that we are having. Then we need to carefully choose the statistical treatment. What type of the statistical treatment that we should choose, that we'll discuss little later. And then we can proceed with the softwares, or we can use prompts in the AI. AI comes little later, right? First we need to understand these two things. Now, why I'm saying this, I'll also demonstrate all these things. In the last session, we actually going to construct, generate few variables, and we also decide what type of the statistical techniques that we can use utilizing the artificial intelligence, right? So far what we have covered, data is classified into two parts: qualitative and quantitative. Moreover, more specifically, there are three types of the variables: nominal, ordinal, and the scale. Scale is nothing but a combination of interval and ratio. So this is the thing that we already have discussed. Now, let me take you to the types of the statistics. Okay. So what are the types of the statistics? So this part already we have seen. This part already we have seen. What are the different types of the statistics? Please, those who are having some statistics background, please tell me what are the different techniques available in the market, statistical techniques, tools, methods. Can someone tell me? By the time I'll just have a sip of water, warm water. Yes. Pankaj sir, Deshmukh sir, Gayal sir, Harish sir, Kulkarni sir, Gayatri ma'am. What are the statistical tools available? What statistical techniques that usually we use? Okay, fine. So there are only four. Actually, there are two statistical actually methods. But for a simplicity, I have made it into, I classified it into four different types. The first is the descriptive statistics. What is descriptive statistics? Descriptive statistics include tables, simple tables, frequency tables, percentage, etc. Graphs, simple graphs are also included in the descriptive statistics, and numerical methods like central tendencies, dispersion, and skewness. Right. So descriptive statistics is the actually the beginning part of the statistical this thing, right? Whenever we are having data with us, usually we start with the descriptive statistics. Whenever we are having data with us, always start with the descriptive statistics. Then comes the inferential statistics. What is inferential statistics? Inferential statistics includes hypothesis testing, and in that again the parametric test and non-parametric test been included. What is the meaning of descriptive statistics? What is the meaning of inferential statistics? That also we'll try to understand little later. Then associative statistics. In that there is a correlation, right? In correlation, again, partial correlation, simple correlation, rank correlation. And at last, there is a predictive statistics where the regression modeling part comes in to the picture. Linear model, log-log model, lin-log, reciprocal model, and quadratic, and there are many other types of the regression, right? So whenever we are having data with us, where to start? Can we directly go to the modeling part? Can we directly go to the correlation part? Or can we directly go to the hypothesis testing part? So answer to this question is, whenever we are having data with us, usually we should start with the descriptive statistics first. Simply, you go to the tables, you try to draw some graphs, you try to give numerical treatment, descriptive numerical treatment first. Then you can go to the inferential statistics. Then you can go to associative statistics. And then you can go to the predictive statistics, right? So always you should start with the descriptive statistics, and at the end we can go for the predictive statistics. During the next session, we'll try to understand all these 4 different statistics without using any formula, and also we'll try to understand that how can we use AI, how can we take the help of AI to use different statistical techniques on our data. So as mentioned earlier, data is classified into 2 parts only, quantitative and qualitative, correct? So the types of the statistical methods are also are different for the categorical and numerical variables. Means for the qualitative and quantitative variables, there are different descriptive techniques, right? So there are different descriptive techniques for the qualitative and quantitative. There are different statistical techniques for the qualitative and quantitative. Inferential techniques are different. Even associative statistical techniques are different for the qualitative and quantitative, and predictive are also different for the qualitative and quantitative. And that is why we cannot apply any statistics on any type of the data. We should be very careful when we are applying the statistical techniques on a particular type of a data. So here is a kind of a brief table, and this table shows us that if we are having the qualitative data, what type of the descriptive numerical treatment we can perform, and if you are having the numerical data, what type of the descriptive numerical treatments we can perform. So for inferential statistics and associative and predictive are concerned, the available statistical treatments are mentioned here. And in a simple observation, we can understand that for qualitative variables, there are very limited statistical tools are available to apply for the qualitative variables. And there are plenty of statistical tools are available to apply on the quantitative or the numerical variable. In my observation, I have seen many PhD students and many researchers who actually use the Likert scale and the ordinal or the nominal data when they are collecting the information. But actually, for the nominal and ordinal data, there are very less statistical treatments available. If we collect the numerical data, then I think we can use plenty of statistical tools. Now, let me start with the descriptive statistics. Means in further few slides, what we will try to understand is what actually we do in the descriptive statistics. Then we'll try to understand what actually we do in the inferential statistics. And then we'll try to understand what actually we do in the associative statistics. And finally, we'll try to understand what actually we do in the predictive statistics. Again, without using any formula, we'll try to understand the meaning of all these things. So what I'm saying these are the 4 types of the statistical methods: descriptive, inferential, associative, and predictive. And there are the different tools, techniques available in these different 4 statistical methods. Now, in upcoming slides, we'll try to understand meaning of most of the tools, right? Without using any formula. And then we'll try to understand how the artificial intelligence can be utilized, can be helpful identifying these tools on our variable, right? Now let me start with the descriptive statistics. So far, do you have any questions from the participants? I'll just take a break of just 3 to 4 seconds. By the time if you are having questions, please raise your questions. You can put it in the chat box also. Okay. 356 मीन मीडियन मोड. ओके 10 मिनट पहले बोला गया था पंकज सर ने. व्हाट वी डू इन द डिस्क्रिप्टिव स्टैटिस्टिक्स, बताइए, कोई बताएगा? No? This is a very simple question. Fine. Let me start. What we do in the descriptive statistic? Suppose there is one variable weight. How we measure weight? We measure weight in kilogram. Correct? Suppose I am collecting information from the sample data, and my sample is say that n is equal to say that 384. 384 are the respondents. I have collected information on the weight. Now from this 384, there is somewhat weight which is highest weight. Say that 100 kg is the weight, highest weight, right? And there is somewhat lowest weight. I have collected information on the weight. There is somewhat highest weight 100 kg. There is somewhat lowest weight, say that is 35 kg. All they are the graduate students, right? I have collected information on the graduate students. Now, what about the frequency? How many students are there with the 35 kg of the weight? There are very few, one or two students only, right? How many students are there with the around 100 kg weight? There are one or two. But as I move from the towards right from the 33 kg, 36 kg, 37 kg, 38, 39, 34. Actually, the weight is like 35.46, 35.78, 36.7, any number between two numbers, right? As I'm moving from left to right, the frequency number of students are increasing with the respective weight. Suppose here is again say that 40, right? Here is say that 45, right? Say that here is 50, right? Then say that here is 55, right? And so on, so forth, right? So as I move from left to right, it is increasing like this. From the right hand side, as I move from right to left, again, the number of students are increasing, right? So as I move from left to right and right to left, the number of observations, number of frequencies are increasing. And when I draw a particular graph, it will look like this. It has some pattern. So we are working on the pattern. It has some pattern. And if some of you are those who studied the statistics or econometrics, they are familiar with the concept term normal curve. Okay. So normal curve idea also comes from this thing. So we'll talk much on normal curve little later. But before that, let me first make you familiar with the what actually we do in the descriptive statistics. Now, in weight, I'm having somewhat maximum weight and somewhat there is a minimum weight. As I move towards right from the minimum and as I move towards left from the maximum, the frequency, the number of students, they are improving. And there is somewhere, there is a stage where you reaches to the maximum point, right? And that particular variable is having its own design, its own pattern. And that pattern usually looks like this. You collect any data, you choose any variable, that particular variable has its own pattern and it looks like this. It looks like bell shaped, right? And in this bell shape, when we try to find out the central value, then that is known as a central tendency, that is mean median mode. These are very basic concepts in the statistics, right? We all know these concepts. Still, we are trying to understand it in a different way. Why? Because in a further session, I'm going to talk on the hypothesis, and there we need to understand what is central tendency and what is dispersion and the other part. Now, from the center point, if I try to compute the distance between max and min, that is known as a range, right? That is known as a range. Now, if I classify data into four equal parts, how will I classify data into four equal parts? Using Q1, Q2 and Q3. Q1 is nothing but quartile 1, Q2 is nothing but quartile 2 and Q3 is nothing but quartile 3. So these quartiles are the positional values. These quartiles are the positional values which divide the data into four equal parts. It means Quartile 1 is a positional value below which there is a 25% of the distribution, and above which there is a 75% of the distribution. Correct? What about Q3? Q3 is a positional value above which there is a 25% of the distribution and below which there is a 75% of the distribution. What about Q2? Q2 is a positional value above which there is a 50% of the distribution and below which there is a 50% of the distribution. Your Q2 and median are same. Your Q2 and median are same. Anyhow, so from Q3, if we deduct Q1 from Q3, we get the interquartile range. And if I compute the average distance of each and every value of that data, average distance of each and every value from that particular data from the mean, that is known as the standard deviation. So these are the few concepts that we actually compute in the descriptive statistics. So what actually we compute in the descriptive statistics? Simply, we try to compute the central tendency, central value, a particular number which represents the data, and at the same time, we also try to find out the dispersion, right? Dispersion. How far the other values from the central value. So this actually the thing that we do in the design. Skewness is again one part. What is the skewness? If your mean, median and mode are equal, then exactly 50% of the distribution is on the right side and exactly 50% distribution is on the left side, right? But if your mean, median and mode are not equal, either your variable pattern will look like this or it will look like this. It will be either positively skewed or negatively skewed, right? Positively skewed and negatively skewed. All these things are very important, and all these things plays very important role in the understanding of normal distribution and hypothesis testing, right? Now, so positively and negatively skewness and normal or symmetrical. We already have seen this, right? What are the box plot and why we are studying the box plot now? Box plot is closely associated with the skewness. For example, what is a box plot? Box plot is kind of a diagram which tells us 5 different things. It tells us the median, it tells us the maximum value, it tells us the minimum value, it tells us the Q1, and it also tells us the Q3. What is Q3? Q3 is nothing but a positional value above which there is a 25% of the distribution of your data for that particular variable, below which there is a 75% of the distribution. Now, what is Q1? Above which there is a 75% of the distribution and below which there is a 25% of the distribution. This part already we have discussed, right? Now, if your data is symmetrical, if your mean, median, mode are equal, your box plot will look like this. It will look like this. You simply construct a box plot using licensed Microsoft Excel or licensed SPSS or using R or Python or MATLAB. No problem. Now, your box plot will look like this for the symmetrical this thing, data. If your data is like this, positively skewed, then your box plot will look like this. Here in this box plot, you can observe it is inclined towards left, right? And there is, यहाँ पे ये देखिए इसका tail, it's very long. So when your data is positively skewed, your box plot looks like this. When your data is negatively skewed, your box plot will look like this. So there are different patterns, right? Again, we are working on data means what? We are working on data means we are working on the patterns. We are working on the patterns. What is the meaning of statistical results? We are just simply explaining the pattern of my own data. We are trying to explain the pattern of the data. And pattern means what? How it is far from the normality. Normality means what? Normality means this mean, median, mode. They are equal. ठीक है ना? So all these things that we do in the descriptive statistics. There are multiple variables with us, right? And each variable has its own distribution and pattern. Using statistical technique, we can find the pattern and provide the meaning. So far the research is concerned, we collect the information, we collect the variables, we collect the data, and each variable has its own pattern, and we try to explain the pattern using the statistical techniques. Now, is the story same with the nominal and ordinal data? Means whatever I explained here as of now, each variable is having its own pattern. It is true for the scale data. What is the scale data? Scale data is nothing but a numerical data, right? It is a numerical data. Now, is the story same for the nominal and ordinal data? Let me check. Suppose we have collected data on the gender, right? Here is the data on gender, X, and I have assigned a code. One is to say that for female and two is for the male. I have collected this data. Then I'm having this, say that column chart or the bar chart. Huh? Can we compute central tendency mean here? Huh? Can I compute central tendency here? No, we cannot compute mean here, right? So for these numbers are concerned, I can simply use the formula and I can compute somewhat and I can get a result like 1.45. But this 1.45 has no meaning because one is a female, two is a male, they are the respondent. I cannot say that my respondent are averagely 1.45 means they are neither female nor male. No, I cannot come to this conclusion. I can go for the mode. Mode is the highest frequency. Who is in the more number? I can simply identify there are the female in more number. So I can say from my data, my female are the more respondent in my this thing, my data. Male are in less number, right? And can we compute the dispersion? Again, the answer is no. We cannot go for mean or standard deviation here. Story is same with the ordinal also. Here again, how can I compute the mean? I cannot compute mean. In the case of weight, I can compute average weight. Averagely 52 kg is the weight of that particular, say that data set, right? But here, can I say anything? Because if I compute mean, it will appear like, say that 3.25. So 3 number is assigned to, say that neutral, and 4 number is assigned to satisfied. So it is neither neutral, neither satisfied. It is somewhere here. It lies somewhere here. So how can I interpret this? I cannot interpret this. So again, in ordinal data, again, the mean will not work. Here, you will have to go with the mode. You will have to go with the mode. Story is same with the hypothesis testing. If you are having the ordinal scale, where you have used the Likert scale, 1, 2, 3, 4, 5, how can we apply t-test? We cannot apply t-test. T-test has a different test actually. T-test we can apply on the scale data. I have seen in many research work that on the Likert scale, they are applying the t-test. No, wrong method. How can we interpret the things? I'll come to the t-test little later, but when you are having the nominal or ordinal data, how can we apply t-test? There are non-parametric tests for the nominal and ordinal data. What I'm trying to say here, you will understand little later when we'll go to the hypothesis testing part, right? Let me take you to the next slide. So what actually we try to find out from the descriptive statistics? We try to find out the basic nature of the data. It helps us in the further statistical treatment. We try to find out how far it is from the normal distribution, how far it is from the normal distribution, how far the mean is from the median and the median is from the mode, the differences, how far it is from the mean and max, and there are many things. Simply, descriptive statistics simply tells me the nature of the data, what type of data that I'm having with me, right? Now, where to begin with? Usually, whenever we are having data with us, please Don't go for the modeling directly. Don't go for modeling. No. Don't go for modeling. Don't go for directly for the hypothesis testing. No. This is also not recommended. Please start with the descriptive statistics plus first. Once we understand the nature of our data, then and then only we can go to the hypothesis testing and the modeling part. Anyhow, after this, we'll go for the inferential statistics. In last two slides, let me make it clear where to begin with. Whenever you collect the data, first you try to understand. First, you try to means identify what type of variable that you are having, nominal, ordinal, or scale. Then accordingly, simply you try to construct the tables, frequency, cross tables, and stem and leaf display. So what is stem and leaf, vagara, that I'll not talk on. Then you go to graphs. You just construct the graphs first, then you will understand the things, and then finally you can go for the statistical treatments in descriptive statistics only. So these are the basic statistical treatments, numerical treatments available in the descriptive statistics. So as of now, in the first session, I tried to make you familiar with the what are the different types of the statistical methods, what is the meaning of the variables. And now I'll go to the inferential statistics, right? Now, for the inferential statistics, let me take you to the slide. Fine. Now, in the next session, what we'll try to understand here is what is inferential statistics and what is hypothesis testing, what is one sample status, independent sample status, then one-way ANOVA, two-way ANOVA, correlation and regression. So that much part that we'll cover in the next session. As of now, I tried to make you familiar with the basic terminologies, right? So what we have covered here, basic terminologies we have completed, measurement of scale also we have completed, types of the statistics we have completed. Now we'll go into the introduction to inferential statistics. We'll understand how actually we can construct the hypothesis and what are the different tests available, when to use a particular test and on what type of the data, and finally we'll demonstrate how can we construct different models or how to decide what type of the statistical tool to use on our data, right? So if it is possible for you, please be ready uh, with the internet connection on your laptop or the computer. So in the last part of the second session, we'll demonstrate something. We'll actually utilize AI, and we'll try to find out that what type of the models that we can construct using our own variables. Fine. So I think so far the first session is concerned. I'll stop here. We'll take 5 to 10 minutes of break, and then again we'll start at 4:30. So we are having around 10 minutes in our hand. By the time, if you are having any questions, please raise the questions. There are no questions? Good. So over to you, Gupta sir. Can we take break for 5-10 minutes?
Yes, sir. Yes, sir. There is a provision we can take for 5-10 minutes.
Ah, 4:30 we'll start again.
Sure, sir.
I'll start sharp at 4:30. Fine. Thank you.
Okay, sir.
Fine, I'm back. So we'll start at 4:30 exactly. One more minute. By the time, I'll request the participants to just uh, put your research theme in the chat box. Whatever your research area, the interest research area. So we'll take the examples from that and then we'll continue for the hypothesis and regression thing. See, in the second session, what we'll try to understand is what actually is the hypothesis and what are the different hypothesis testings available, modeling, regression modeling, and then finally using artificial intelligence, how can we construct the model? Means how can we get the ideas of modeling and the different tests. So I'll request the participants to just put your uh, research themes. I'm saying themes, not the titles. Like one of my student is working on health economics, or someone is working on the economics of education. Fine, air pollution studies, it appears. Okay, air pollution studies. What about others? So that I'll understand what type of the audience is this. So accordingly, I'll frame my talk. What about others? I hope you understood me. What I'm saying, just you will have to put your research theme or a research variable on which actually you worked previously or you are thinking to work in future. Whatever is the theme, research theme. Like, as I said earlier, my PhD student, one student is working on health economics, one is working on economics of education, one is working on financial inclusiveness, right? Now here I have seen air pollution studies, someone is working on. So what about others? It seems there are a few doctorate persons also. So I'll request them to just put your research thing. Why I'm saying it? Uh, as we'll go further in the hypothesis part now. Okay, tourism studies, right? So very heterogeneous group. Tourism studies. What about others? Okay, by the time the people put their research theme, let me start the session. Let me again start sharing my screen. So in this second session, what I'll try to explain is, see, in the previous this thing session, I tried to make you familiar with the few terms like sample statistic, right? Population parameter, descriptive statistics, and as I said earlier, once we are having data with us, usually we should start with the descriptive statistic, right? Previously, we used to go for the different softwares and we used to import the data and we used to apply the statistical techniques. But now in the world of AI, I think there is really no need to, means there is no much more need to understand the software procedures. AI can assist us and guide us in the statistical treatment on your data. Anyhow, but before going to AI, we first need to understand what are the different statistical techniques available with us and at least the meaning of all these things. Anyhow, in the descriptive statistics, we already have seen that we are having the different variables in our study, right? From the participants, okay, only 3 themes are visible contemporary issues of society, right? Air pollution and tourism studies, right? Fine. Now, I'll request participants to just, you can put your themes. Addition to that, you can just simply put the variables also. Fine. So if you put the variables, we can consider few variables and accordingly I'll analyze them. And if someone is not someone is hesitating to put the variables or the theme, no problem. At least you try to correlate your variables with what I'm trying to say here during this second session, right? So in the previous session, as I said, we all are working on different variables, and each variable each variable has its own pattern, right? And what actually the statistics do? Statistics help us to analyze this pattern, right? So in a descriptive statistics, usually we try to find out what is the nature of my variable, single variable, and there are multiple variables. So we try to find out what is the nature of my own data, right? So your data, your variable can look like this, right? Sorry, look like this, or your variable can look like this. So there is somewhat pattern of your variable, and you try to explain that pattern, and that is a descriptive statistics that we already have seen. Fine. Healthcare in society, there is one more this thing. So I'll take the note of it. Healthcare in society. Fine. Now the thing comes, whatever is the whatever are the themes that you mentioned here: air pollution studies, tourism studies, contemporary issues of society, healthcare in the society. What are your key variables? So your key variables which will address your research problem. So you need to identify, you need to pick up those key variables, and those key variables have their own pattern, and using AI and using statistical tools we can analyze that pattern, right? That is actually is the research that what I feel. Now this is kind of a treatment on the sample data. See, in this, suppose I'm having a data on age in the years. Data looks like this. This is kind of a graph that has been drawn using the SPSS. Here the mean is 36.94. Mean, what is the mean? Mean is nothing. This is a statistical term. Mean is nothing but the central tendency. What is the central tendency? Means which number represents the whole data. 36.94 means the average age of my respondent is 37, right? In a simple, this is a simple statistical tool, no problem. Standard deviation is 12.12. It means averagely all other numbers are averagely 12 years more or less, right? What does that mean? Let me again explain. Once we understand this, then and then only we'll able to understand the hypothesis part, right? That is why I'm spending much time on it. So I have collected some dummy data, and on that data I have drawn this curve histogram with the normal curve, and in this normal curve here is somewhere my mean is there, that is 36.94, that is 37. So 37 years is my average age, and standard deviation is 12.19. It means from the average my data averagely spread around 12 years, means above 12 years and below 12 years. That is the meaning of, in a simple way, not in a technical way, but in a simple way, right? Standard deviation is 12 years. Story is same with height. Now, if simply we look at these graphs, histogram with normal curve, They both look symmetrical. Symmetrical means previously we have seen, right? Each variable has its own pattern. And here is the central tendency, 50% on the right side, 50% on the left side. Tick. You can have the graph like this or this. There are only three types: positively skewed, negatively skewed. Now, if I have drawn two graphs, both the graphs are looking symmetrical. They are known as a fairly symmetrical because skewness, your skewness 0.09 means is very minor number, right? Minus 0.02, it is again a very less number, right? Now let me take you to the next slide. In the weight 0.27, it is again a very normal number. So it is fairly symmetrical. It looks like fairly symmetrical. Now, if I come to the income 0.76, it is kind of a significant number, right? So it looks like this. You can see that, right? It has somewhat tail. What is skewness? Those who are familiar with the normal distribution curve, you can see that if I draw a histogram, it also looks like a normal distribution curve, right? And how far this curve is far from the normal distribution curve is actually a hypothesis testing that we can say. Not on the technical ground, but in a general way, for the sake of understanding, we can say that. Now, those who are not understanding what I'm saying, let me take you to the further slide. What is inferential statistics? See, those who are not having the statistics background, they will also understand this. So inferential statistics actually is used to generate conclusion about the population's characteristics based on the sample data. So inferential statistics is the statistics which actually every researcher uses or utilizes, and your conclusions depends on this. Your conclusion depends on inferential statistics, not on the descriptive statistics. Descriptive statistics is just a introductory part. Inferential statistics are they plays very important role in your conclusions, right? So how it works? How does the inferential statistics works? Let me take you to the further slide. So usually we make certain claim about a population characteristic. For example, you are working on an air population. If you are working on a tourism studies, you are working on contemporary issues of society, or you are working on a healthcare, right? But you must be having some focus area, whether you are working on the air pollution of the world, or you are working on a particular, say that the area or particular somewhat something. So you need to understand first your population, right? And for that population, you make a certain claim, you make certain statement, and then what we do, then we opt for the probability sampling. Then we choose the samples, and from the samples we collect the data, and our sample value approximately represents the population value. We consider that whatever is my sample data and whatever I draw from that sample, it will speak for my population. It will speak for my population. And what is inferential statistics? Whatever is your sample value, whatever is your sample value, how far it is from the actual population value, right? How far it is from the reality, right? How far it is from the population value. It is quite confusing for you, but anyhow, as we move forward, you'll understand what I mean to say. Now let me take you to the graph again. So what actually we do in the inferential statistics? Here is the population. There are many these things. So we choose sample. Once we choose sample, we give a statistical treatment and we obtain the sample statistic. We obtain something, some values. And on the basis of this sample statistic, we try to infer, or we try to find out whether the sample statistic is different, significantly different from population parameter or not. How far my sample statistic is from the population parameter. That is the meaning of hypothesis testing. So before going into the hypothesis testing different techniques available in the statistics, let me first make you familiar with the basic terminologies like normal distribution, sampling distribution, and few others without using any formula again. So here is a normal distribution curve. What is normal distribution curve? As I said earlier, now, as I said earlier, each and every variable is having its own pattern. We already have discussed on it. But there is somewhat an ideal situation of a distribution. There is somewhat an ideal situation. What is ideal situation? Ideal situation is considered as there is a kind of a curve where mu is exactly at the middle and your whole curve is divided into two parts, one standard deviation, two standard deviation, and third standard deviation. And on the opposite side, minus one standard deviation, minus two standard deviation, and minus three standard deviation. And the whole area, this whole area covers the 100% of your responses. What does that mean? It means if I have collected information on my variable, all those responses lies here in this 100%. Fine. But again, we are having 1, 2, and 3 standard deviation, right? So what is the meaning of 1, 2, and 3 standard deviation? Let me explain you. First, let me read these things. So it is a continuous distribution, right? It is symmetrical with skewness 0. Skewness 0 means mean, median, mode are equal to, means they are same. And the normal distribution provides the basis for statistical inference. See, all your hypothesis testing depends on this, right? Your hypothesis testing depends on this. So once you understand this, then and then only will understand the testing procedure. Though the artificial intelligence help us in hypothesis testing, though the person who is familiar with the statistical techniques will give us with the results, but until and unless we don't understand this thing, will not able to interpret or will not able to give proper meaning to our results. So please pay attention to this thing. See, many variables have distributions that closely resemble the theoretical properties of normal distribution. Now, let me take you little further. So the total area under the curve is 100%. Yes, 50% on the left and 50% of the right of the mean. So here is the mean. This is mean of what? This is mean of population. Again, are we working on the population? No, we are not working on the population. We are working on the sample statistic. But this is the ideal situation of the population. In a statistics, they are considering if you collect the information of each and every element of the population, your curve will look like this for that particular variable. I repeat, if you collect the information of each and every element for a particular variable, and if we draw a curve will look like this, where exactly 50% of the distribution will be on the right side of the mean and left side 50%. Your mean, median, mode will be equal. This is an ideal situation. And what we try to find out, actually, we never collect the data on the population. We actually collect the data on sample. So where actually your sample lies in this ideal situation. Does it lie here or does it lie here? And whether if it lies here, is it near to mu or is this a near to mu or is it too far from the mu? Huh? So there we take the decision. So what does that mean? Let me take one example. As we move forward, जैसे जैसे आगे जाएंगे, we'll understand it. So the total area under the curve is 100%. The area under normal curve are tabulated and shown in Z table. There is Z table. Now we'll not go into the technicalities. Simply for every variable, there is a ideal distribution table or ideal distribution graph. So this is ideal graph. Ideal means a very perfect graph. Actually, our variable is not perfect, right? How imperfect it is, that we are trying to analyze using the statistics. Now, the values lies between 1 standard deviation and 2 standard deviation. They cover 68.26% of the responses. So I'm having X, I'm having many responses. Now, whatever is my standard deviation, 1 and -1, all the responses in between these, they are my approximately, they are my 68% of the my responses, right? Now, what about say 2 standard deviation? That is 95% of the responses. They lie in this region, right? This -2 +2. So how much of the respondents data lies here? That is almost 95.44% of the respondent data lies here. And see carefully, my arithmetic mean, median, mode, they are also lies here. They also lies here. So this is the data which actually affects the central tendency, dominating data that we can say. Now, if I go further, +3 and -3, 99.72, it means almost 100% of the responses are, they lies here in this region. So this is the region, graphical part of the variable, right, where your responses lies into, right? So this is actually an ideal graph. Now let me take you further. Suppose, now for the sake of understanding, suppose the mean is 50 and standard deviation is 10. How we compute this? Simply, if I collect data on X, if I perform statistical technique using software, simply I get the mean. Mean is the average value and standard deviation. As you all know, in the previous session, as I said, average means the central value and standard deviation is how far the values far from the central value. So if my mean is 50 and standard deviation is 10, then what does that meaning? Here the mu is 0. Here is 1 standard deviation, 2 standard deviation, 3 standard deviation. Now if my X bar is 50 and standard deviation is 10, it means 50 plus 10, 60. So this 60 and 50 minus 10 standard deviation 10, this, so this portion is actually 65% of the responses lies here in this part, right? Now, what about 2 standard deviation? If my mean is 50, right, and I just wanted to calculate how many respondents are there lies in between these 2 standard deviation, what I'll do, 50 plus standard deviation 10 plus 10, that is 70. 50 minus 10, 40, minus 10, 30. So here around 95.44% of the respondent lies here in this region, right? So this is simply basic statistics. I'll not go much deep into this. See, what I wanted to say here is, suppose I'm having a data of age, and if I draw a kind of a diagram like here, and it looks like this. So this is kind of a pattern that my variable is having. So average is 36 point. So this is around here, right? Now, how much is my standard deviation? Standard deviation is 12. So 36.94 means 37. Standard deviation 12 means 37 plus 12. This is the number. Then again plus 12. This is the number. So here is the line. And again, where is the second standard deviation? Here. So 95% of the respondent, they lies here in between these two numbers, 61 and 30. So once you understand this, +1, 2, 3 standard deviation on right and left, I think we'll go further for the Z distribution. Now, Z distribution is nothing but an ideal distribution. Fine, I'll not talk much on this. We can convert any sample number to the Z. Means we can convert X to the standardized ideal Z distribution, right? Using the formula, but I'll not go into the formula. Now let me take you to the sample distribution. Again, what we are trying to understand here, we are having two things with us. One is a population and other is a sample. We are collecting information on sample only, right? We are collecting data on the sample, correct? Now, from the population. From the population, you are identifying the sample. Now take this example. If we take many samples of size 30 from sample population, what does that mean? So here is your population and person A is a researcher. He comes into the picture and he chooses 30 samples from this population. 30 samples he chooses. He collects the data and he has collected a data X1. He is having the data with him. Now there is a person B. He also comes into the picture and he also tries to collect the data. And he collects the data on again 30 different samples, and those samples are known as, say that, X2. Now, whether the results of A and B will be same, here is the question, right? Like A and B, there are multiple researchers who can identify different 30 samples and they can collect the data and they can come out with some conclusions. Okay, what does that mean? It means there is a term sampling distribution in statistics. What it means? If we take many samples of size 30 from the same population, each sample will have its own mean, right? And the theoretical distribution of these sample mean is called sampling distribution. What does that mean? It means like, let me show you this graph. So this is an ideal graph of your population, right? This is ideal graph of your population. You choose a particular sample. The way you have chosen a sample, suppose your graph is this is a graph of A, suppose this is graph of B, this is graph of C. This is again a theoretical and logical. This is an ideal graph, logical graph for the population, for that variable. And using probability random sampling, you choose a particular samples and so whether whatever the conclusion you are drawing, whether your conclusion is far from the actual estimated population mean or it is near to actual that estimated population mean. In simple terms, are you near to the reality? Whether you are so far from the reality in air pollution or in tourism studies or in contemporary issues or in healthcare, are you whether your results are near to the reality of the population, or are they far from that reality? What I'm saying, again, I'll repeat. This is a theoretical or logical way, ideal situation. Means it is mentioned in the statistics, right? Whatever the sample, you are having different sample data, right? Different variables, X, Y, Z, whatever it is. Using your sample data, statistics theoretically designs the ideal population distribution, right? Ideal population. Statistics imagines the ideal situation of your population for those variables, and it tries to answer whether these variables, whether your sample statistics is far from the real estimated population mean. Is it far or is it near? Okay, I hope you understood what actually the hypothesis testing is. Anyhow, though you don't understand this, no problem. The way we are, will try to understand how to construct hypothesis and how to perform this. Again, that part is again different. This is the theoretical way that we are trying to understand what actually the hypothesis is. Now again, there are few terms, point estimate, critical. ये short में हम समझ के लेंगे. See, so here again there is some distribution, and here is a critical value plus 1.96 and minus 1.96. If you remember previously, slightly if we go ahead, here is plus 2 standard deviation, and here on the left side there is slightly minus 2 standard deviation, right? But we are going to consider plus 1.96 and minus 1.96 because the area between these two things are exactly 95%, right? This is 95% level of confidence, right? So on the right hand side 2.5 and on the left hand side 2.5. Whereas the 2 standard deviation, if we consider plus 2 standard deviation minus 2 standard deviation, it appears to be 95.44 something, right? Anyhow, now this is ideal situation, right? This is a rejection region. Now, if your sample data, if you collected the information on a particular variable, you calculated the mean, and your mean is here, somewhat here, in the ideal normal curve, right? So whether this mean is near to mu or it is far from the mu, how will we decide? To decide it, there is a critical value. There are a few terminologies like critical value and level of significance and many others. Just for the simplicity, just try to understand that if your sample statistic, I'm using different terms. If your sample statistic lies here in this rejection region, it tells me that there is a significant difference between mu and your sample statistic. There is a difference, right? There is a difference between the ideal situation and the sample result, right? If your x bar lies here, again you will say that there is a significant difference. But if it lies here somewhat, here, you will tell that no, there is no significant difference. You are near to the ideal situation. Every researcher tries to what he tries to explain, he always try to explain how far is the actual scenario from the ideal scenario, right? So we always like to be here in the rejection region. Now, so anyhow, if the x bar is close to mu, do not reject null, and if x bar is far from mu, reject null hypothesis, it's fine. How far is the significantly far? Actually, that we determine using critical value. Anyhow, I'll not go much deep into it because we are not having much time in hand. Anyhow, it was kind of a theoretical this thing. Hypothesis testing, we already, okay, this is again important part. See, we already have seen that when to reject and when to accept the things. But actually, this is very easy. While we are using the AI and when we will use the softwares, it becomes very easy to take the decision. Because if your p-value is less than 0.05, we reject the null and accept alternate. Statistically, वो बहुत easy है, but this part is very important and crucial to understand. Okay, this already we have seen. I'll just explain you what are the different types of the test. So there is a Z test, there is a T test, chi-square test, F test, and few others also. But we never use Z test. Why we don't use Z test? Because we never collect the population data. Z test is a kind of a theoretical test, ideal test for the sake of understanding only. Because here if you want to apply the Z test, you need to know the standard deviation, and to need to know that standard deviation, you need to know the each and every value of each and every element. And as I said earlier, in research, we never collect the information for each and every element. So we never apply the Z stat, right? Then in almost all studies, researchers, they apply this T statistic. So we always apply the T statistic, where the population standard deviation is not known. This is the condition. If your population standard deviation is not known, though you can apply the T stat, right? And there is one more rule. If you are having the sample size less than 30, then you can use T stat. Other way, if you are having the standard size greater than 30, then also you can use T statistic. Please again pay attention to this. In many cases, researchers misunderstood this. Only if you are having the sample less than 30, then only we can apply T stat. No, this is not the case. If you are having the sample size more than 30, then also you can apply the T statistic. Right? If we are having the sample size more than 30, we can apply Z statistic, someone can say, but no. Why we cannot apply Z statistic? Because though we are having the sample size greater than 30, our population standard deviation is not known. We don't know the standard deviation of the population. That is why T stat is more popular in use. Chi-square is used for the categorical variable non-parametric test, and F-stat is used for the for the scale data. Fine. So in the last previous 2 hours, what we try to understand, variables are classified into two parts: qualitative and quantitative variables, nominal, ordinal, and scale variables, and finally we reach to the hypothesis testing. If you are having the nominal and ordinal data, you can only apply the non-parametric test. And if you are having the scale data, you can go with the parametric test. Now, how to go with the parametric and non-parametric test? Let me explain you. So what are the different non-parametric and parametric tests? Parametric tests are applied only for the scale data, right? Where the responses are in the numbers, numerical data. And if you are having the qualitative data, you can apply the non-parametric test, right? What are the different tests? So here are the few tests. For in the parametric test, one sample t-test, independent, dependent, one sample, one way ANOVA, two way ANOVA. Non-parametric, chi-square, and few others. Now in the upcoming few slides, we'll try to understand the meaning of these tests and chi-square test from the non-parametric, and then we'll go for the correlation and regression. Now let me take you to the further slide. Fine. Now, see, in the previous 2 hours, we tried to we just talked on the theory part, right? Now, if there are the participant who could not understand the theory, and if they are thinking in now I'll not understand these tests, then no, that is not going to happen. Though you did not understand anything from the previous 2 hours, still you will understand what actually these tests mean and how can we use these hypothesis tests in our research. What I'm saying, in the previous 2 hours we talked theoretical way. Now onward we are going for the kind of a practical. So even if you don't know the theory, you can simply understand what actually the one sample t-test, independent sample t-test, dependent sample t-test, correlation, regression means, and how to utilize them in our research. So in t-test, there are mainly three hypothesis tests: one sample t-test, independent sample t-test, and dependent sample t-test. So what is the meaning of it? So let me start with the first, one sample t-test. What are the prerequisites? If you are having a data if you are having data with you, what type of or what are the prerequisites that should be there in your data? ऐसे कौन सी चीजें हैं जो आपकी डेटा में होना चाहिए? Then and then only we can apply one sample t-test. When we can apply the one sample t-test? When in your data you are having a population mean and you are having a sample mean. What does that mean? For the better understanding, let me take one example. For example, when to apply one sample t-test? For example, is the average daily calories intake of the student different from the 2200 calories? Now, 2200 calories is mentioned somewhere in the government report or somewhere, right? So this is the known population mean. Population mean means you know the mu. Mu means the center part. From the your population, you know a particular number and you just wanted to compare this number with your sample data, right? Another example is, suppose someone is working on the air pollution, right? Now air pollution index is somewhat, how you measure air pollution I don't know. Can you tell me how you measure the air pollution? Any term, any variable? And government is saying that
So,
this is actually
we are measuring particulate matter.
pardon?
Particulate matter, sir. Particulate matter, the dust particles.
Okay, dust
The
particles.
concentration of the dust
Now
particles in a given volume.
government must have said a particular number above which that is not good and below which that is good enough, right? And if you are having that
Correct, sir.
number, if you are having that particular number, and if you collect the sample data, and then if you compare it statistically using AI or in using softwares, and if you are trying to say that your sample data, whether it is significantly different from this population mean or not, then you can definitely perform the one sample t-test. So I'll request all the participants, whatever is your research theme, now onward, for every hypothesis testing and for regression modeling and for correlation, try to correlate your research theme, your variables with these hypotheses and try to make some sense. For example, as I said, here I have given one example. You are having one number from the government data, government sources, or the previous research work. That number should be clearly mentioned, and you just simply wanted to test whether your sample mean your for that particular single variable is different than the population value. So here what we are comparing, the population value is compared with your sample mean, right? That is why this is known as a one sample t-test. Your sample for that particular variable. I hope you understood this. If you understood, just show me the thumbs in the chat. Is it clear to you? Okay, now let me take you to further. Now what is second? Second is independent sample t-test. What are the independent sample t-test? Here, actually, what is the prerequisite here? Here the prerequisite is we need to have two independent samples. What does that mean? It means whatever is our theme, in our data, we should have two different samples. For example, I already have given one example. Is the average income of urban household different for the rural household? For example, dust particles. Suppose here the variable is dust particle. Dust particle in the urban region and rural region. So dust particle in the urban region I have collected, dust particle in the rural region I have. So these are the prerequisites. I should have the data like this, right? Once I'm having data like this, then each sample data will have its own pattern, and then I'll try to find out whether is there any significant difference between these two independent samples. Two independent samples. For example, someone is working on the healthcare, right? Healthcare in the urban, healthcare in the rural, or healthcare in Mumbai say that suburban this part and central Mumbai, or it depends on you how you design it, right? So it depends on you. Only the thing is that we cannot blindly apply independent sample t-test on anything, right? To apply independent sample t-test, we need to have a particular prerequisites in our data, in our variables. Our variables should be in a such a way that will able to apply the independent sample t-test. I hope you understood this. Again, in independent sample t-test, in urban and rural case, as we already have seen, here we'll find the same mean, same variance. Means for the urban and rural, the same pattern is there. There are chances that we can find the same mean. Mean is same, but the variance, the dispersion is different. We can find the different mean, but the variance is same. Variance means the dispersion of that, the pattern, dispersed pattern is same. Different mean, same variance, but with smaller effect. There are different methods again. So I'll not go deep into this. Now come to the paired sample status. What is paired sample status? Now suppose I observe on the same sample previous something, and if I collect the information on the same sample after something. For example, before COVID, say that the appetite and after the COVID appetite. Okay, tourism studies, before COVID tourists and after COVID the tourist. Now again उसके अंदर आप variables कैसे define करोगे, it is up to you. Now if in my data I'm having a kind of a variables where I'm having a situation like before and after, right? Here is an example. This student's test score improves after special coaching. So students score before the special coaching and after the special coaching. And is there any significant difference between these two? To test such kind of data, we use paired sample t-test. I hope you understood this also. Now, this is a box plot. You can simply understand that before the condition was like this and after the condition is like this. And at least in a visual way, we can simply say, yes, there is a difference. But when we go further and we apply hypothesis testing, it gives us a clear picture whether is there any significant difference in these two conditions or not. Now, let me take you to the one-way ANOVA. What is one-way ANOVA? I hope you are able to understand all these things. I'm going to use artificial intelligence to construct all these things on your own team. How to construct, how to give prompts, that also we'll discuss soon. Now, in one-way ANOVA, what we do, in one-way ANOVA, I'm having three different income groups, anything more than two, right? Is the mean health expenditure different across the three income groups? What are the three income groups? High income group, middle income group, and say that low income group, or anything. Any three schools, say that school 1, school 2, school 3, and I have conducted one test, IQ test, say that whether the IQ score is same or they are different. So either I'm going to get this pattern, all three are same. Mu 1 is equal to 2 is equal to 3. What is mu? The whole school A, all the students from school A are equally intelligent to the school, all students of school B are equally intelligent to the all students of the school C. All students when I'm saying. So this is for all students, but I'm collecting the sample information only. So sample 1 from the school A, sample 2 from the school 2, sample 3 from the third school. And on the basis of these samples, I'm trying to make some infer about the population, right? So Either they are same or they are not same. Somewhat two schools are same, one school is or not same, or all the three schools are different, or all the three groups are different. So when we are trying to identify the significant difference between three different groups, then I think we use one sample t-test. Then we use one sample t-test. Now let me take you to the two-way ANOVA. Compare between two or more independent variables with different groups within. Suppose, here is one example. Does the discipline arts, commerce, and science affect salary differently for experienced and non-experienced person? Now, what is the key variable here? Here, the key variable is the salary. Salary is in the numbers, right? And you can see that here is the discipline, arts, commerce, science, and here is work experience. So these are the independent variables, right? Discipline. Who is dependent? Salary. Salary depends on whom? Salary depends on from which discipline you comes from. Or are you experienced or are you without experience? So when you are having such kind of a data, then we can go for the two-way ANOVA between the groups. And it tells us whether is there any significant difference between these different groups, right? What is chi-square of test? Chi-square test of independence. Chi-square, we use this test only when we are having the nominal or ordinal data. We don't apply it on the scale data. Again, please pay attention to this. I have observed that in most of the research work in PhDs and in MPhils, usually the people go for the chi-square independence test. Chi-square independence test been considered as not much powerful test actually. If you are applying a t-test or f-test or one-way ANOVA, two-way ANOVA, then those tests are actually been considered as a powerful test because they depends on the scale data, right? Whereas chi-square test depends on the categorical data. There are few limitations. When it is highly impossible for us to collect the numeric data, and if we have collected the categorical data, then only we can go for the chi-square test. But if it is possible for you to collect the numerical data, please go for the numerical data, right? So what is chi-square test? Chi-square test is actually, it tests whether the two categorical variables are independent of each other. And how to measure it? Whether the pattern of bar changes across the categories, then there is evidence of association. What does that mean? Suppose here, if I'm asking a question, whether you choose the tobacco or whether do you smoke, so smoking habit, and the answers are in say that yes and no. And I'm asking the another question, gender, male and female, right? So for the male and female, if the yes charts are like this and no charts are like this, they are almost similar. It means there is no association. Male and female are independent for the small smoking habit. But if they are different, for example, for male, this is like this, and for female, yes is like this, right? And for male, this is like this, and for female, so this is uneven. Then the smoking habit is associated with the gender. Mean a particular gender is more inclined towards the smoking, right? So it simply tells us the independence of the two different variables, gender and smoking. Then we'll come to the correlation. What is correlation? Simply, for the sake of understanding, if I have collected a data on study hours in a day, how many hours you studied, and the obtained marks, right? Marks by the students. How many students? Say that 300 students data I have collected. So I'm having two different variables. One is hours studied, right? How many hours you studied, and the other is the marks, right? Now, and I have plotted the points, right? If we look at these two variables are positively correlated, because if you are studying means you are spending more hours in study, you are going to get good marks, and if you are spending more less hours in study, you are going to get less marks. Hypothetical way, once I collect the data, I can obtain some value. That value is known as a R. And if it is more than 0.05, it is high degree positive correlation. If it is more than minus 0.5, high degree negative correlation. These are the types of the correlation coefficient. I'll not go into deep here. Simply, you are going to get such kind of graph. If such kind of scatter graph you are going to get, then that is known as a high positive correlation. This is known as a low positive correlation. This is known as a high negative correlation. This is known as a low degree negative correlation, right? Now, I'll come to the regression model. So what is regression model? Again, this is a theoretical way that we are trying to understand. In the last 30 minutes, we are going to use artificial intelligence and we'll try to understand how can I construct, how can I choose the variables, and what type of the statistical tools, techniques I can apply for my variables. That part will cover in the 15 to 20 minutes at the end, because artificial intelligence performs very fast. Let's say. So the last part here in a theory way, in a regression, usually we are having at least we should have two variables, and one variable should be a dependent variable. Dependent variable means a variable whose value depends on the next another variable, right? And here is the independent variable. So in my data, if I'm having the information data numbers on y and numbers on x, then I can construct the model, right? Minimum two variables are required, out of which one should be independent variable. Suppose here is my income, and x is, say, that my education, right? Education or anything else in numeric way if you have collected. Now, if my income I have collected like 2,000, 3,000, 4,000, or 10,000, 15,000. So this is in the thousand numbers, right? For simplicity, we have used only single digit. And here is the education, year-wise education. Now, what does that mean? Once I'm having such kind of data, and if I use AI or statistical software, and if it gives me kind of output, what does that mean? It means if 1 year of education, if I add 1 year of education, my salary, my income will increase by 3,000 rupees. 3,000 rupees. Because my data was in the 1,000 rupees. Right? When you are having only two variables, that is known as a simple linear model, two variable model. Now, if I am having multiple variables, one dependent variable and more than one independent variable. For example, education, experience, skill. So I have collected information on it, and then I have constructed this model. What does that mean? It means if one additional year of the education, it will add 2,000 rupees in my income, right? One extra year of the experience will add 1.5, means 1,500 rupees in my income. A particular skill, one skill, addition in one particular skill will give you 6,000 rupees extra. So this is actually a dummy data. I just wanted to make you familiar with how actually we construct the models in our research. Now let me take you to the last part of this session, that is how can we use AI and how can we perform statistics using using AI. So far, if you are having any question, please raise your questions. Just in a minute. At 5:30 we'll start immediately. By the time I'll take sip of water. Do you have any questions so far? Last part is very important, please. Fine. Now, let me take you to the crucial part, that is the role of AI in statistical analysis. Fine. Directly, indirectly, we all are using the artificial intelligence. Most of us are using the artificial intelligence. Now, we'll talk on how can we use AI in statistical analysis and interpretation wisely and in a responsible way. How actually our brain works? Uh, we all know that there are different 4-5 parts in our brain. There are different lobes in our brain, right? And in those lobes, there are millions of neurons. And those neurons actually, what is the function of those neurons? The neurons actually transmit the information throughout the body using electrical and chemical signal. It gives you the signal. So these last parts, synapse, are very important in our brain. So they give the information, right? So information shifts from one neuron to the another neuron, again from the another to another, another to another. So this is a complex system in our brain. Why I'm telling you all this? Because I just wanted to make you clear that how actually the human brain works and how actually the artificial intelligence works. What is artificial intelligence? Artificial intelligence refer to a computer system capable of mimicking human intelligence. But what is the base for this? How come artificial intelligence mimic us? वो अपना ह्यूमन थिंकिंग को कैसे पहचान रहा है? For that, we need to understand a quite short history, right? How does the AI company works actually? So AI company, they collect the data, they manage the data, they are having the robust infrastructure with them, cloud-based infrastructure, and they develop the algorithm, they develop the models, and the algorithm actually it acts as a brain, right? So algorithm in AI company actually act as a brain. So what is algorithm and thing, that I'll not speak much on that. Just for the sake of understanding, just try to understand how does actually AI works, right? Now, it requires huge energy, and 20% of the expense is on the cooling mechanism, because it generate heat. AI generate heat. ठीक है ना? Now, what is the present status? Why artificial intelligence is so popular nowadays? Huh? It was there in 50s, 60s, and 70s also. Artificial intelligence was there in the 50s, 60s, and 70s. In the last means previous 3-4 decades before also, the AI was there. But in recent past, it became so popular because post 1990, fastest computers been utilized, used, and large digital data set been generated. Even in India also, if you observe in last 1 or 2 decades, we started using smartphones, smart watches, smart TV, Android TV, and many more other things. And whenever we are using all these things, we are generating some data, and that data is getting stored somewhere. Somewhere means in the AI company, and though that data been utilized by artificial intelligence to generate few things. So in the recent past, when we are using different digital tools, technologies, AI is actually getting flourished, right? Since 2020, artificial intelligence can now generate new things. So that is known as a generative AI. It means AI can write, summarize, assist in research, right? And there is nothing wrong in taking the assistance from the artificial intelligence, but in a proper way. How to use it, that also we'll talk about. So I'll not much speak on this because we are having only 20-25 minutes. So I'll take you to the practical. What is prompts? Prompts are nothing but the instructions that we give to the AI system. And your results, everything, whatever the outcome that you are expecting from AI depends on the way you give the prompts to AI. So which AI is good is not actually a good question. What type of the prompts you are able to give is actually a good question. If you are able to give proper prompts, any AI will give you a very good answer or any a very good output or any useful thing, right? So prompts are nothing but the instructions. Now let me perform few prompts. Okay, why prompts are important? I'll not go into these types of prompts. I'll not go into this. Okay, key takeaways. Prompts are instructions given to AI. Better prompts leads to better output, and researcher remain responsible for the final content. So this is very important. Now, let me take you to the practical. We are actually going to give some prompts using ChatGPT. Why we are using ChatGPT now in this session? Because ChatGPT is more familiar with you all. You can go for the another artificial intelligence tools also. Like so, for the statistics is concerned, you can go to the Julius and the other things. But for the sake of understanding, I'll go with the ChatGPT for the simplicity. Now, when we'll give the prompts, please do not type everything at once. Don't make prompts so large. Type it step by step and in a small way and wait for the output. You will have to always wait for the output. And then you should move to the next prompt. So let me take you to the prompts. So what is the practical? Here the practical is, here we'll try to understand, suppose I'm having a research problem, anything, tourism studies or whatever it is, we'll try to construct the different variables. Now again, from the audience, please tell me your, say that research theme and a particular objective. Can use that will construct here using ChatGPT, or say that I'll use my own. One of my student is working on say that health economics, right? So what I'll do, simply I'll open the ChatGPT. I hope you all are able to see ChatGPT open here. Is it visible to you all? Is it visible to you all?
Yes, sir. It's visible, sir.
Fine. Now simply I'll go here and I'll paste these lines. My research title or my research theme is health economics in urban and rural settlements in Maharashtra, right? And my objectives are, for that, suppose I'll open the document where the objectives are mentioned. Now let me search my objective, my students' objectives actually. Suppose your objectives are ready. Okay, my objectives are here. Let me copy. Let me put it here. My objectives are right. And what is the last sentence? Please explain the research problem, key concept and scope of the study in clear academic language. So I'm having the research theme. I'm having somewhat the objectives with me. I have simply put the prompt. Now, if I click on the arrow, ChatGPT start working on it. Now it is generating, right? You can also use these prompts, and you can also generate something, because in these slides what I'm going to do is I'm going to search out the different means what type of the statistical modeling or the hypothesis testing or the variables, the information that I should collect, everything I'll take the ideas from the ChatGPT, right? Now, so here is my research problem. Health is both. Now it has been written. I'll not read much in detail. So here are the key concepts like what is health economics, availability of health services, accessibility, affordability, healthcare expenditure, government health measures, health inequality, scope, everything been provided by ChatGPT. Now, if we consider the ethics, I'm not going to copy and paste these things. I'll just read it for the sake of understanding, and I'll try to make it relevant to my own understanding. Right? Now, what is the next prompt? Let me take you to the slides. My next slide is identification of the problem. What is identification of the problem? If you look carefully, based on my research title and objectives, identify the key variables. If you are quite confused with the variables, what variables are appropriate to your research theme? And to identify that, I am taking the help of AI. Based on my research title and objective, identify key variables required for primary data collection. Consider dependent, independent, control, and other variables. Now, when I'm giving these prompts, before giving the prompts, we need to understand what are the different types of the variables, what are the measurement skills, and what are the different statistical techniques. And that is why previous last 2 hours we spent on understanding all these things. Now, let me simply copy this part and put this part there in the ChatGPT. Now, simply I'll go back to my ChatGPT. I'll simply paste it. Previously, I already have provided ChatGPT with my title and the things, and simply I'll put it. Now, it will give me the variables. Now, a person who is working on the healthcare can also correlate, right? Now, the dependent variable, outcome variable, healthcare utilization, it is showing me. It is also giving me the measurement indicator relevance. It also provides me with the relevance of the study. You can see how this variable is relevant in my study. It gives me the idea, right? Out of pocket health expenditure, right? Affordability index. Okay. So there are many things been provided by ChatGPT, and there is nothing wrong in this. Once you understand what type of the variables that you require, right? I think it makes some sense. Means using this information, I can collect a very good kind of a data, right? Economic variable, household income, vagara vagara. Social variable, educational level, gender of household, caste, household size, and there are many other. Almost 40-50 variables been provided by ChatGPT. Now let me take you to the next slide. What is my next slide? My next slide is again the prompt. We are working on the prompt. Sorry. For the identified variables, specify data type, categorical, numerical, scale of the measurement, and the data collection method. Present the answer in structured table. So this is one more prompt. Let's see what happens if I put this prompt in the ChatGPT. Let me copy this. Simply put it here. Okay. Press. Now, it gives me in a table. What type of table? The variable, the category. You can see that. So here are the variable names. Here are the category, dependent in whatever data type, numerical or categorical, whatever it is. scale of measurement, ratio, or what type of data collection method, survey or secondary, whatever it is, right? The way you ask the prompt, it will give you the answer. So here I'm getting, I have received multiple variables, right? Independent variables, economic factors. There are many others, right? If you want it in a more specific way, tabular format, you can give more prompts, no problem. Now let me take you to the further slide. Okay, now drafting interview schedule. Design interview schedule structured to facilitate descriptive analysis, inferential hypothesis testing, and regression modeling. It will give you so, right? So let me again put this prompt in ChatGPT. So I'll just copy and paste, right? And we'll have to wait for the schedule. Fine. So descriptive analysis, inferential or regression modeling के लिए this schedule will be helpful. Okay, it only suggests us. It only provide assistance, right? Now here again, the section A, B, C, D, E, F. Artificial intelligence is working on its own. Now, actually, the question comes from where it is giving us all these things. As I said, all the artificial intelligence companies are having their own cloud-based these things. And all the previous studies or all the relevant studies, wherever been conducted previously, they are stored somewhere. And from there, artificial intelligence tries to give you the best possible framed questions, right? And that is a good sign actually. That is a good thing. हाँ, अगर हमें अच्छा क्वेश्चनर मिल रहा है जिसको हम रिलेवेंट कर सकते हैं, then that is good thing. Now, still it is working on my questionnaire. So there are section D, section E. There are many things, right? Now, it depends on me that if I think that some part I can omit it, I can reduce it. I can add a few new things from my side, no problem, right? So there are many things to, means there we can do many things with the ChatGPT or any artificial intelligence, this thing. Now let me take you to the ओके हाइपोथेसिस का ये भी दे दिया उसने, स्टेटमेंट भी दे दिया, एग्जांपल्स भी दे दिया है, राइट? रिग्रेशन मॉडल्स भी दे दिया है, राइट? व्हाट टाइप ऑफ द मॉडल्स यू कैन कंस्ट्रक्ट. ओके, नाउ लेट मी टेक यू टू द फिफ्थ. टेबल्स आई विल नॉट वर्क ऑन, और लेट मी कॉपी एंड पेस्ट, क्योंकि विदाउट डिस्क्रिप्टिव वी कैन नॉट गो फर्दर. Simply I will copy and paste this prompt, and I'll click on this arrow. I have asked which survey variables are appropriate for frequency distribution cross. कौन से वेरिएबल पे स्टेम एंड लीफ निकालना है, क्रॉस टेबल निकालना है, उसके बारे में पूछा गया है. ठीक है ना? इट गिव्स अस द इनसाइट. ओके, so this is for the table. What tables are more suited for what type of the variables, right? Now then again I'll go for the ग्राफ्स के बारे में भी वो है. I'll omit this, I'll skip this. Descriptive statistics भी है, I'll skip this part also. Now, okay. Hypothesis. Based on the research objectives and identified variables, formulate suitable null and alternate hypothesis and suggest corresponding statistical test, right? Present the output in table indicating the hypothesis and required variable. Now let's see what happens if I put this in the artificial intelligence. If I'm asking this to AI, let me check. I'm asking to construct the hypothesis based on my variables. The variables being generated by AI only, right? You can see hypothesis and statistical test. So as per my objectives, the AI is constructing the hypothesis, right? The mean distance to nearest health facility is same for rural and urban settlement. So variable type, ratio, nominal. So whatever the required information that actually is necessary been provided by the artificial intelligence. It provides you many things, but as I said earlier, if you don't know what is the meaning of independent sample t-test, if you don't know what is the meaning of two-way ANOVA, if you don't know the meaning of one-way ANOVA, then there is no use of using AI. That is why the last 2 hours we spent on understanding what is nominal, what is ratio, and what is independent sample t-test, one-way sample, and the other things, right? And in whole session, we did not use or utilized any formula. In a simple way, we try to understand what is the meaning of one sample, independent sample, paired sample t-test, one-way ANOVA or two-way ANOVA, and how to make sense, how to make it relevant to your variables. That we try to understand, right? Now, so this is the way that we can construct the hypothesis. Now, how to perform statistical test? You can give the prompt here. I just wanted to perform one sample t-test on my data. These are my variables. Tell me the steps. It will give you the steps. Then accordingly you perform it, and then you get it. If you simply put your data in the AI and ask, give me the results, there are high chances that it will give you wrong answers, right? So it is always better to go to the softwares, Spaces, Excel, R, Python, and then try. Or you can go to the Julius. There are specific artificial intelligence where you can generate the results. You should not go to the ChatGPT then. Don't go to ChatGPT if you want the statistical results. For that, there are different artificial intelligence tools available, right? Now let me take you to associative statistics छोड़ दो, predictive statistics. Let me put this in this. Let me ask AI this. From the collected survey variables, identify and suggest the appropriate regression model. I am asking artificial intelligence to suggest me a regression model, right? So let me put it here. Let me ask artificial intelligence. Now, again, this is generating. So first model is here, second model. So according to the objectives, been generating. So there are 5 models so far, 6 models, 7th model. So many. What artificial intelligence is doing here? AI is helping me. AI is telling me the possible models which I can construct, the possibility, probability, right? The way I have provided AI the prompts, the variables which I have shown AI, on the basis of those variables, that many models I can construct, and that is being suggested by AI. So if you are having the data on the variables, this is good to use the AI and to get the suggestion which appropriate model suits my data, right? And let me take you to the last slide. AI for detecting statistical mistake. Review the following statistical analysis plan and identify any conceptual or methodological mistake. Explain why they are problematic, right? So you can use such kind of this thing also, the prompt also. Review the above statistical analysis plan. उसी का प्लान हम उसी को बताएंगे. Let me paste it. Review the statistical analysis plan and identify the mistakes. It will work on its own. It will give us something. It will provide you the problems. the way means problems out of the information being generated in the previous these things, right? So you will have to read it and you will have to understand it, and accordingly you will have to shuffle your writing and change your variables and change your statistical technique. So anyhow, I just wanted to highlight here is that yes, you can simply use AI, but before that you need to understand what type of variables that actually you are carrying, what type of data that you are carrying, and you need to understand what is the meaning of statistics, what are the different types of the statistical techniques, and what statistical technique can be utilized or used for or applied on what type of the variable. If you are having that much of the basic understanding, I think uh, you can use artificial intelligence for the statistical analysis and interpretation in your research. There are a few other artificial intelligence, best artificial intelligence for data analysis. Julius is a very beautiful one for the data analysis. You can you try to means try to learn this Julius AI. It will help you. ChatGPT advanced data analysis is also good. Rojiro, Accio, and there are many others, but this Julius is kind of more specifically for the data analysis, this thing. So again, I'll come to the last slide, and this was my first slide at the beginning of my session. What were the questions? Should statistical techniques be planned before or after data collection? For me, I think we should plan it before the data collection. Statistical techniques needed to be planned before the data collection. We cannot apply any statistics on any type of data. If you're having nominal ordinal scale, accordingly, you can apply the appropriate statistical tool technique. There is really no need to memorize the formula, right? If you know the meaning of the statistical those methods, that's enough for you to use the statistics in your research. Do we use statistics just to calculate number or to extract meaningful evidences? So we always try to use statistics to extract meaningful evidences. But in many cases, there are chances that the people use statistics just to calculate few numbers. पूछा जाता है हाइपोथेसिस किया है क्या, हाँ किया है, मॉडल किया है, हाँ किया है, नहीं. We should use statistics to extract meaningful evidences. What matters more, variables, process, and the interpretation? For me, variables are very sensible. So variables matters the most. If you choose your variables very carefully and in a very proper way, if you collect the information in a proper way, right? If you measure the variables in a proper way, I think you'll end up with the good results. If software or AI calculates everything, what is the researcher's role? Researcher's role is to handle AI and the softwares, right? Because you know your variables. Variable का मतलब क्या है? What is the context of the variable? That is only known to the researcher only, right? And what improves the research more? Large data or correct measurement? For me, the answer is the correct measurement. With this, I think I should stop here. We are having only 2-3 minutes. So if you are having any questions, please raise your questions. I'll stop here.
Yes, participants, if you have any question, you can unmute yourself and you can ask the questions. I guess, sir, there is no question in the chat box. So can I ask you one question?
Please.
Sir, I am studying, I am doing research on air pollution studies. So I'm recording the concentration of the particulate matter in the air. What are the effects of this particulate matter on the human health? So if I'm talking about the data which I'm going to collect over a period of time, like 1 year ka period. So in this, there was one anomaly which happened, like Utopia में volcanic eruptions हुआ था. So because of that, suddenly the concentration of the particulate matter in this Mumbai region increases sharp. Like there was a sudden increase in the concentration of the particulate matter. So if I'm considering my data points, so should I consider that data point as well, where the concentration of the particulate matter increased due to one of the anomaly which occurred in that particular year?
See, you can go with it, but again, so far the statistical language is concerned, and what I understood, what you are saying is something has affected something, right? There are 2, 3 different variables, but every variable having its own pattern, but उसके ऊपर जो impact हुआ है, it is not because of only 1 or 2 factors. There are multiple factors. Now it depends on a researcher how you are justifying that thing. Means as you said that जो इरप्शन हुआ उसका इम्पैक्ट यहाँ पे हो रहा है, so you should be enough capable to justify it in a powerful tools कि उसी की वजह से यहाँ पे इम्पैक्ट हो रहा है, but you can go with the statistics. Statistics only provides you the proofs and supporting for your statement. So whatever you are saying, उसका सपोर्ट आप स्टैटिस्टिक्स में से रिजल्ट निकाल के उसको सपोर्ट दे सकते हो, नो प्रॉब्लम.
Okay, sir. Understood, sir.
How ChatGPT remove plagiarism? See, again, ChatGPT, please don't copy and paste from the AI. Simply, as I said, whatever the prompts that we used here in these sessions, those prompts were only for the suggestions. Those prompts, not a single prompt was like, ki, provide me the writing on this, give me the final interview. No. I was asking what are the variables, this is my objective, what are the alternate variables, how can I collect the information. Okay, so if it depends on you, अगर आप prompts अच्छे से देते हो, you are going to get the proper suggestions. If you are asking to generate research writing, definitely it is going to be caught in the plagiarism, because now plagiarism softwares are more intelligent than ChatGPT and artificial intelligence things. उन्हीं का कंपनीज है वो लोग, हाँ, वो कहीं से ढूंढ लेंगे. Artificial intelligence is only for the assistance, right? हमको उससे काम करके नहीं लेना है, हमें उसको यूज करना है. ओके, ठीक है. देर आर नो क्वेश्चंस, देर आर नो अदर क्वेश्चंस. फाइन.
Okay. So, sir, I would like to conclude this session by giving a formal vote of thanks. So please allow me to propose a formal vote of thanks.
Yes, please.
Yeah, good evening, everyone. So as we bring this session to a close, I would like to express our sincere appreciation to Dr. Sagar Kondekar, sir, for a truly enlightening session on statistical thinking, inference, and the responsible use of AI in research. Sir, your emphasis on steps in handling research data, when to use descriptive statistics, inferential statistics, associative statistics, and predictive statistics, and also classification of data into various skills, giving proper treatment, will definitely help us in handling our research data in a more correct and organized manner. Also, sir, thank you for highlighting to like how to ask the right research questions and understanding the role of statistics in real life. You also highlighted how to use AI, fair use of AI in research using proper prompt. The example and the fundamental perspective you shared, sir, will certainly help us approach the data more thoughtfully. Along with this, we are also grateful to Dr. Dhanashri Mahajan, Madam, Director of UGC MMTC, Dr. Bamu, Assistant Director, Dr. Rafe, sir, for their meticulous planning in spoon conduct of this 16th FIP. A special thanks to Mr. Gaurav Jadhav sir for his behind the scene team for their efforts in ensuring seamless experience. Last but not the least to our participants, thank you for your active engagement and thoughtful questions. We hope you will carry forward the insights gained today in your work and future endeavors. Thank you, sir, and thank you, dear participants.
Thank you. Thank
So
you
with
so
this,
much.
we formally
Actually,
conclude
this
our
morning
today's
I
session.
was suffered by my throat infection. I was not able to speak. But anyhow, I tried, I managed to speak. Thank you.
Yes, sir. Yes, sir. So we received a lot of, we gain a lot of information from your session. Really helpful, sir. Thank you,
Great.
sir.
All the best. Thank you. Bye.
Yeah. Thank you, sir.